Hello, good evening, everyone. So welcome to the second day of our image processing workshop. So yesterday, we got the introduction to image processing, as well as we discussed the basic OpenCV functions, like how to open an image and how to do operations on the image, and like how to write the image. And also then we moved on to how we can deal with videos, right? And how we can load videos into our code, and how to play them, and how to do the basic stuff, right? So that was what we discussed last time. Now today, what we are going to do, we are going to move on to a new topic called point operation. So else we can call it as pixel-wise operations as well, right? So that's what we are going to discuss today, right? So now point operations, so pixel-wise operations. Why this is called pixel-wise operations or point operations, right? So now here we are going to we know that image processing, right? So we are going to process images. That's what we call image processing, and we discussed that last time. And here point operations, so we call pixel-wise operations. What happens here, we are going to do this operation pixel-wise. That means for each and every pixel, right? So if you are going to do some operation in an image, for each and every pixel in that image, that's called point operation or pixel-wise operation. Now point means a pixel, right? So that means pixel operations or pixel-wise operations we call, right? So again, if you are going to do something, some operation to each and every pixel in a particular image, that's called pixel-wise operation or point operation, right? So first thing, right, I will start from here, right? Changing the color space, right? Changing the color space. So what it means by changing the color space, here we are trying to now if you have, let's say if you have a color image, so we can convert it to a gray color image, or we can convert it to a black and white image, right? So we can change colors of a already existing image. So that's what we call changing color spaces, right? So in order to do that, we will straight away move on to the code, right? So first, you know that we can load the image simply using this imread command, right? We can use the imread command, and you know that we can show the image. So this is something that we did last time, right? So this is basically this code is going to open the whatever the image, and also then that image will be okay. Now give me a second. Okay, right. So what we can do, as I mentioned earlier, we can load the image, right? Then we can show the image like this, right? We need to show the image first, right? Okay, now this is what we discussed last time, right? So this is something that you are aware of. We need to import the OpenCV library, right? So you are going to open the image like this, right? So now we have a function, another function in OpenCV called convert color, right? So how you can call that function? cv2 dot convert color, cvt color, right? So then what you have to do is you have to pass. So this takes two parameters, this convert color function or this method. takes two parameters. The first parameter is the image that you need to change the color, right? That you want to get the color change. That image you need to pass. Then what you have to pass is you have to pass the color conversion flag, right? Color conversion flag. I will explain about this color conversion flag later, but I will do example, right? So I'm going to use a color space like color BGR to gray, right? So this is the first color conversion flag that we are going to use today, right? And then what we can do is we can get the next image. I mean, like let me call it like new image, right? New image, right? So now what happens? We pass this image, right? And our function is convert color, right? OpenCV convert color function. Then we have to pass the image that we need to change the color. Then we have to provide the color changing flag, right? Color conversion flag we say. So this is one of the flags available. There are many flags available, right? So this is one flag available, and here this function returns a new image. So let us print it, and I mean show this, and let's try to get the idea what this image looks like, right? So this is what you are going to see now. This is the new image, right? So you can clearly see that, okay, the image, the flower is now converted into a grayscale image, right? Grayscale image. So that's done using this function, right? So simply that's done using this function. Now the thing here, now don't think that this convert color function changes color images to gray images. No, that's not the task. This convert color function is there to change the color spaces of images, right? So now we have many other color conversion methods like BGR to RGB. Now what happens in BGR to RGB? Now what happens is the components change, right? So I will show you the output and then you can understand, right? So now the B and R are changed, right? So BGR now becomes RGB, right? So the color components change, right? So then we have like the HSV color format. We are going to discuss this HSV color format later, right? So this is another color space, HSV. We will discuss about this HSV later in our workshop. And also we have like YUV. Now this YUV color format is usually used in self-driving car applications, this kind of YUV color space, right? So there are many color spaces available, right? So if you want to see all the color conversion flags available, what you can do is you can run this code that I have provided here. You can run this code and see the flags available, right? So these are the flags available, the color spaces, the color conversions that we can do in OpenCV, right? Got it? So I hope you got the idea. Now the convert color function is basically about what? Changing color spaces. So you can change the color, right? And get a new image, right? Now why this is called pointwise operation? Now why this comes under pointwise operation? Any idea? Since we are going to do this for each and every image, each and every pixel of the image, right? So each and every pixel is converted to gray, for example, right? So now, like, can you guess how the BGR or the color image is converted to gray? Any idea? Any idea how this conversion is done? Now, in a color image, we have three components, right? So we have three components in a color image, right? Like BGR or RGB. Then we are going to convert it to a one component, gray, the gray component, right? So how we are going to convert it? Any idea? Now, if you take a single pixel, right? So now there are two, right? So there are three components in a single pixel. Now I have shown you a single pixel. Now this will be converted to a single value, right? How it's done, right? The most common and the straightforward method is taking the average of these three components and that will be used as the gray value. Understood, right? So you know that in a color image, a single pixel contains 3 values, right? A single pixel contains 3 values. So how we are going to convert it to gray? Basically, we are going to take that 3 components and get the average, and that average will be assigned as the gray value, the single value of the single value, and that becomes the gray color of that image, right? Understood. So there are many other methods, like for other color spaces, they use other other conversion methods, but what I explained was for gray conversion, right? So there are many operations, many methods, many equations that we can use to do this conversion for other color space like UV, HSV, YUV, likewise, right? Got it? Okay, now you may be wondering, okay, what's the application? Like, why we need to change the color from a particular color space to another color space? Now, this seems straightforward. Like, the color to gray, that's straightforward. But like, why we need something like this HSV, right? So, is there any specific application? Yes, we will see the application. Like, why we need to change some like BGR to HSV, and there's an advantage. We will discuss this later in our workshop, right? So then you will get to understand the importance of this convert color function, right? Okay, so the next method that we are going to discuss under the point operations, right? Point operations. The next one is image thresholding, right? Image thresholding. That's what we are going to discuss now. So in order to so in order to do that, I have a sample image, right? I have a sample image from the samples folder. This gray image.png. Now this contains a what? This contains a set of coins, right? So you can see this image in your samples folder. I have provided the materials already. I hope you got this materials with you, and so this is what I'm referring to. This is what I'm referring to, the gray image, right? So what we are going to do now, simply we are going to do image thresholding here. Now, what this image thresholding means, right? Image thresholding means this is basically like converting a image into a black and white or a binary image. Now here, like earlier we discussed about, now I think you know, right, what binary image is, right? So we can convert this kind of a gray image or this kind of a color image into a binary image. So that's what you call thresholding, image thresholding. That's what you call image thresholding, right? Okay, so right. So then how this thresholding is done? Quite simple, right? So I have opened the image, you can see, right? Then there's a function called threshold, right? So I will show you example, cv2.threshold. cv.threshold. Then this is the method that we are going to use for converting image into a binary image, threshold function, cv2.threshold, right? Then we have to pass the original image. Then we have to pass 2 values, right? I will explain about these 2 values later, right? These 2 values I will explain about them later. And the thresholding method, the last parameter will be the thresholding method, right? So we will do, we are going to learn about 1, 2, 3, 4, 5, right? So 5 thresholding methods, right? So that means we are going to discuss about 5 thresholding methods. First, we will discuss about the binary method, and later we will move on to the next, right? Others, right? Okay, so we will use the binary thresholding method. So this is the thresholding method. We have 5 methods, main 5 methods. There are some other methods as well, but there are 5 main methods. So we are going to use the first method first. Then later we will move on to the next values. And here I will discuss about these 2 values in a minute, right? So this threshold function returns 2 values, like it returns a Boolean value, like we discussed earlier. Can you remember the red value for the source dot read. Similarly, right, this returns you true values, right? This is the image that this is the threshold that image, right? And this is like a Boolean value 0 and 1. We will discuss about it later. But anyway, we will see the output. Then you will understand what that what we are going to see here, right? Sorry, now I will discuss about this gray, the CMap gray in a minute, right? Okay, so this is the output that you are going to get. See, right? This is the output that you are going to see. So you can see this gray image, right? So we had the gray image, and that gray image is converted into a what? A binary image. Now you can see that here there are no any intermediate colors, no any intermediate gray colors. There are only black and white, right? Only black and white pixels are available, right? Okay, now these are the two values that we need to consider, right? So carefully listen what happens here. Now in a gray image, you know, right? So gray image, what's the pixel range? I mean, pixel range in the sense a pixel can contain values between what and what? What's the value range of pixels in a gray image? Yes, you know that. Yeah, it's 0 to 255, right? So it's something that we already know, and it's 0 to 255, right? So what this function does, right? So what this function does, this function converts all the pixel values which are greater than 80, right? All the pixel values which are greater than 80, they make it 255. That means all the pixels which has a value greater than 80, right? They become white, or they become 255. Others, that means all the pixels which has a value less than 80 become, right? They become black. Understood, right? So that what happens in like these, like that is what happens when you use these two values, right? So all the pixels which has a value greater than 80 becomes 255, that means white. All the pixels which has a value less than 80 becomes black, right? So that's what happened in thresholding, right? Now the thing is, okay, so you can play with these values and see, right? So if you put 100, let's see. Now you can see like, right? So this area becomes also black, white, right? So now we are making all the pixels that less than 100, right? So earlier we did like the pixels less than 80 black. Now we are going to right, we are going to make all the pixels less than 800, right? So more pixels becomes black, right? So you can see like if we put 200 here, we will see that almost all the pixels are, yeah, almost all the pixels becomes white. That means all the pixels here are what? All the pixels here are less than 200, right? So here, now that also makes all the 120 will use, let's see. Now, so can you see? Now that means this area, right? So this area is the, I mean, this area contains, now, okay, let me ask you a question. Okay, so this is the output when you are going to get, like when you are going to use 120 and 255 as these threshold values, thresholding values, right? Now, then you can clearly see that this area has, right? This area has become white, right? Okay, let's say like, okay, this area, right? Right, so this area. Now, can you tell me, right? Can you tell me roughly, okay, can you tell me these pixel values, right? So are they like, are they less than 120 or greater than 120? What do you think? This area, huh? Yes. Yeah, they are greater than white, right? So that's why they have become those pixel has like become white, right? Got it? And also now we can play for this, I mean play with this value, and like I found out that we can use 80 and we can make the coins extracted, right? Now this is a big thing. I mean, like here we have converted this image, right? So we have made the background white and we have made the foreground black, right? So give me a minute. Okay, right. So sorry about the interruption, right? Now, uh, now here the 80, when you say it, you can see like that means these values are what? They are less than. Now these coins are less than, they have a value less than 80 and all other pixels have a value greater than 80. That's what we say. So here using this simple method, you can see now this is also a point-wise operation, right? Or pixel-wise operation, right? Now we are going to like go through each and every pixel, right? So we are going to go through each and every pixel and compare the value, right? So then we see, okay, whether this pixel is greater than 80 or not, right? So we are going to go through each and every pixel and decide whether it's less than or greater than, right? That's why you are going to get right? So that's why this is categorized under pixel-wise operation, right? Okay, so we have other methods as well, right? So we have other methods as well. So we will now see the other methods, right? So we have another method called thresh binary inverse. This is nothing but the inverse of the other one, right? Inverse of the earlier one, right? That means if you put like thresh binary inverse here, you can see the inverted image of this, right? Got it? And the other thing is to zero, right? Or trunk, right? Right? Trunk. So what this means, right? So this should be trunk, not trunk B, right? So here now what has happened? What has happened here? So if you compare it with the original image, what has happened here is right. So all the pixel values less than, sorry, all the pixel values, right, less than 80 no, right? No. Now we have a question here. Are 80 and 25 standard values to convert image by? No, right? Now it depends on the application, right? So now, sorry, I forgot to mention it. Now this thresholding, we can use it for many applications. We are going to use it for many applications in the coming, today and next other days as well. So this thresholding can be used for object detection and many applications. Now here, it's depend on the application. I mean the value, and it depends on the application. Now, for example, let's say that we want to detect coins and we want to like separate the background and the coin in this image, right? So for that particular value, 80 is good, right? That particular value 80 is good, right? So likewise, now let's assume the application here, right? The application that we are going to consider here is basically like I mean separate the background and get the coins extracted, right? So for that application, for this image, the value 80 is fine, right? Value 80 is fine for this application, right? Got it? Now this is not for all the applications, but application wise, the values changes, right? So you have to decide what's the value suitable for your application, right? Got it? This is only for example, right? Anyway, now this trunc method, right? So trunc method, what it does, right? It keeps all the pixel values greater than, it's going to make all the pixel values greater than 82 wide, as the earlier case. All the pixel values greater than 80, right? They will be they will be converted to y. And all the pixel values less than 80, right? All the pixel values less than 80 will keep as it is, right? So they will be kept as it is, right? Earlier case, all the pixel values less than 80 became 0, but in the trunc method, all the values less than 80 will be kept as it is, but all the values greater than 255, all the values greater than 80 will be converted to y, right? So similarly, we have another method. So that's called to 0, right? To 0. This is like the inverse of the trunc method, right? To 0. Right? So in to 0, what happens? All the pixel values greater than 80, right? This value, right? All the values greater than 80, they will be kept as it is, right? So they will be kept as it is, and all the values less than 80 become black. All the pixel values less than 80 becomes black, and all the values greater than 80 kept as it is, right? So that's what you call the to 0 method. Now you may be wondering, okay, like I'm glad you asked. Now this is not a fixed value for all the application. Depend on the application what you want to extract, right? What's based on the image. Likewise, those application, the values changes, right? So we will discuss some examples later, right? So keep this thing in mind now, and also we will discuss about like how we can use this thresholding method for practical applications later, right? For now, just get the idea what thresholding does and the thresholding methods available, right? Now this is a very simple method. Now I have as you can see, I have implemented the same thing, right? I have implemented the same thing like the thresholding method as a custom function. Now this function is implemented by me, right? So I just wanted to show you that this is nothing but comparing each and every pixel value and assigning it, right? So it's nothing. So that's why I have made the thresholding function as a customized function, right? So then I want to show you that this is nothing but, now you don't know what happens inside this cvd.threshold function is called, right? So it's a function and it gives us a return, right? So that's what happens in object-oriented programming. But here I have shown you actually what happens, right? So I have defined a function called myThreshold, right? So this function is made by me, and we are going to get the same image and pass it to myThreshold function with a threshold value, right? And you can see it takes the image and it takes the number of rows and columns through the image.shape. And there are 2 loops, right, to go through the rows and columns, right? Then we are going to compare each and every pixel value, right? I row and j pixel, I row and j column, we are going to get the pixel value and we check whether it's greater than the threshold value provided, 80, right? So if it is greater than 80, we make that particular pixel white or 255, else that means it's less than that value, so we make it 0, right? So this is what the binary, the basic thresholding does, right? So if you do this, you are going to see the same output, right? So I just wanted to show you that it's nothing, but this is what happens, right? Got it? Okay, I hope you got the idea, right? Okay, now with that, now we have implemented, like we know that color changing, we know how to change the color, right? And also now we know how to like perform thresholding, right? Now we are going to go into a practical application. This is a very good opportunity where we can apply the things that we have learned up to now, right? Things that we have learned up to now, and we can do something meaningful, something real, right? So here now I will show you the application, right? I will show you the what we are expecting from this application. Now these are set of coins, right? These are set of coins and not Indian coins, right? Not Indian coins, but these are like Sri Lankan coins, right? Sri Lankan coins. So what we are going to do is, our final application is like to do something like this, to get like a particular coin detected, right? So now this is 2 rupees, right? This is a coin, Sri Lankan coin for 2 rupees, right? So right, so here now we are going to do, like we are going to develop a image processing like a code in Python, where we can like when we have multiple coins, right? So we are going to detect a single coin like this, right? Only 2, right? Only 2 rupee coins, right? So let's see how we are going to do this, and this will be done, right? Simple. This will be done using the concepts that we have already learned, and also in addition we are going to use something called contour operations, right? Contour operations. But before going on to contour operations, let me like go halfway of this small project, right? So I will do some basic concepts, and when we go on to use contour operations, I will explain you contour operations. Not now. We will like go through the the first steps of this project, right? Then later when we need something called this contour operations, and when we want to move it, when we need to know it, I will explain, right? Okay, so first we are going to, as usual, we are going to import our libraries and import this right, coins image, right? Now I want to highlight a new thing, right? So this is the sample folder again, and this is the image, right? So you can see it's a color image, right? It's a color image. So what we can do is we can load it, right? So we can load it. Now we know the function imread, right? So we know the function imread. So what you can do now, I will show you this image, right? I will show you this image. So this is the image, right? So now, like when you read it, now we can convert this. I will explain it, right? So we can convert it to a gray image using the cvd.convert color. You know this, right? Right. Right. So now if we show this image, right, you are going to see something like this, right? So instead of doing it now here, what we have done is we got the image and later we converted it to gray, right? Instead of doing it, you can directly convert it to gray at the, I mean, when you are reading the image, right? So when you read it like this, you are going to get the color image, right? But if you put 0 here as a second parameter, and if you put 0 here, what will happen? It load it as a gray image, so it convert it at the when it's going to read it, at the same moment it's going to convert it and get you the color, the gray image, right? Or else you can, like, without this you can get the image and later you can convert it to gray. That's also could be done. But if you put 0, it will automatically convert it to gray and right? So no need to manually convert it. You can directly get the gray image like this, right? Okay. And there are like other two values we can pass here. I have explained it here, right? So we can pass 0, 1, and -1. So you can read it and understand, like if you put 1, it loads the color image as it is, neglecting the transparency. If there's a transparency in the image, it will be neglected. And if you put -1, that loads the image including the transparency, right? So that's what like these three values we can put at as a second parameter of imprint, right? So 0 basically it converted to grayscale, right? Okay, now here this is the image that we have, right? So anyway, we have the image and we load it to convert. We load it directly by converting to a gray image, right? So you can see now. Usually, when you when we are going to, right? Okay, now this is what we are going to do, right? So our final task that that somehow we need to find a method, right? We need to find a method in order to detect a particular coin. For example, let's say this coin, right? So we want to get this coin detected, right? So that means, so we have to follow. I mean, we can't do this through one step. No, that's not possible. We have to follow several steps and do this, right? So we have to follow several steps in order to do this. So it takes like, I mean, a considerable amount of time, right? And the other thing is like the first step, right? So if I ask you what's the first step there, so we have many steps. The first step should be like don't think that okay, we want to get the, I mean, we need to detect exactly the exact same like this 2 rupee coin. No, we have like first what we have to do is we have to separate these coins, get them separated from the background, right? So we need to get them separated from the background, all the coins, right? Then later, when you have all the coins separated from the background, later what we can do is later we can like get this coin detected. But first what we need to do is we need to get coins filtered from the background, right? Understood. That should be the first step. Now you will know this when you are going to do like some future examples, right? So the first thing, like if you want to detect something using image processing, first you need to extract that from the background. And like in order to do that, we know a very good method that we could use, that is thresholding, right? So what we are going to do is we are going to apply thresholding and get the image like the coins extracted like this, right? So extracted in the sense like we are going to like make it to a single color and we make the background, like for example, we are going to make the background white and the objects that we need black, right? So in order to do that, we can use thresholding. So now, as you asked earlier, now this value is something that we need to figure out depending on the application. Like now, if you use 50, you can see nothing there, right? All the pixels becomes white, right? So if you use 100, likewise, you have like manually see, right? Manually change these values and see. So that's why I told you. Now here our task is okay, getting these coins detected. I mean, coins separated from our right? So coins separated from the image. So in order to do that, like we have to change these values and see which value suits best, right? So now like we can change the values and see. So the application, the final task would be like we need to get the coins and the background separated. So if you, I mean, into two colors, right? So I think now this is something trial and error, right? So I think 200 will be okay. If you use like, yeah, 220 is also okay, right? Like let's say 230. Yeah, this is also 240. Okay, right? So this like 200 is also okay. I mean, like here you can see, right? Right. Yeah, what CMap gray does, right? So I will explain what CMap grade does in a minute, right? So you can see this is this value like 200 is quite okay for our application. Now 220 is also okay, right? Got it. So now then what we need to do? Okay, now we have, right? We have separated coins from the background, right? So we have separated the coins from the background. Now what we need to do? Right? Now what we need to do? We need to, okay, somehow we need to find a method in order to get this thing detected, right? Get this thing detected, right? Got it? So in order to do that, we have to use the contour operations, right? Contour operation. So now I'm going to explain you what this contour operation does. Now here at this moment, you can see, as you can see, like we have many, I mean, all the coins, like we have converted to black, and other pixels are there, right? As the background is like white, right? So now we need to, from these black objects, now these black shapes, we need to exactly detect this one, right? So how we can do it? We have to use something called this contour operations, right? Contour operation. What a contour means, right? Contour is a closed area, right? A closed area of the same color, right? Same color, closed area, right? So here you see, contours can be explained simply as curve joining all the continuous points having the same color or the intensity, right? Right? Got it? So it's like we can simply say, I mean, the definition here is right, bit different than what I'm saying, but for now let's go with my explanation. So I say like this, okay, contour is simply we can say, okay, a closed area, right? A closed area, right, of the same color, right? So if that is a contour, how many contours are there in this image? Huh? How many contours are there in this image? Any idea? Yes, quickly. Yes. How many contours are there in this image? Two contours? No. How many closed areas are there in the same color? Huh? How many closed areas? Yes, exactly. We have 10, right? So we have 10. Why? This one, closed areas, the same color, like black color, closed areas. Right? Got it, right? Okay. So we have a function in OpenCV to detect these contours, the closed areas, same color closed areas. In order to detect them, we have a function in OpenCV, and that's called find contours, right? Find contours. So how we are going to do it, right? Simply like this. You can get the image, and as we did earlier, we can read the image and we can convert it to gray, right? And also we can pass it to the threshold function. And after passing it to the threshold function, what we can do is we can get the thresholded image, right? We can get the thresholded image. So then what we have to do, now at this moment, what we have this image, right? So this image, at this moment, what we have this image, right? Now what we are going to do, using this, from this image, we are going to detect contours, right? So how we can do it? We have a function called find contours in OpenCV, right? So what we can do is cvd.find contours, right? Find contours. So what we can do is we can pass the thresholded image, right? And we can get the contours found, right? So we can get the contours found. So then yeah. And then we have to pass two other parameters. I will explain about these parameters later, not now, right? The first one is the retrieval method of, right? The retrieval method, we call the retrieval method. Don't worry about it for now, right? So we will discuss about this retrieval method in a minute. And also then you need to pass the approximation method, right? So the approximation method. So these two parameters should be passed. So these two I will explain in a minute. I mean, later, right? So not now. I will explain these two later, right? Got it? And also, this returns two values. This function returns you two values: the contours, the closed areas, right? The closed areas, and then the hierarchy, something called the hierarchy, and we don't need to worry about the hierarchy now. So I will do something like this for now. What we are going to do is we will neglect these two parameters that we are going to pass to the function. And also we are going to neglect this hierarchy, what this hierarchy means, right? For now, we will forget them, right? For this time. And I will explain it later, right? These three parameters, right? For now, simply think, right? For now, just simply think, okay, we have a function called find contours. What this find contours function does, when you pass a thresholded image into this find contour, now you have to pass a thresholded image here, right? When you pass a thresholded image into this find contours function, what it does is it returns you something called contours, right? It returns you something called contours, right? So shall we see what this contour is about, right? So we can, like, I will show you the length of this contour, right? Length of these contours, right? So that means how many contours are there, right? So let's see. So we have not 10, you told 10, right? You told 10, but we have 4, 5, 6 contours in this image, right? So hard to believe, I mean, so it says length of contour. So we can see the length, we can check the length of this contour. So it says there are 4, 5, 6 contours in this image, right? So you may be wondering, okay, we have 4, 5, 6, we can only see like 10, right? Yeah. So what I will do, I will draw these contours and show you, right? So there's a function to draw the contours in OpenCV that's called cv.drawContours. So we will use this function to see what are these 4, 5, 6 contours available, right? cv.drawContours, and we can pass the image, and then we have to pass what are the contours that you have detected. Then we have to pass the contour number. I will put -1. I will explain why -1. Then we need to use the color from using BGR, right? So I'm going to use B0, G255, R255. So this becomes yellow, right? Yellow color, and this is the line thickness of the contour, right? So I will explain what this -1 later, right? So those are the parameters that you need to pass. Then what I'll do is I will show these images, like the image and the threshold and the image now. So what will happen? We are going to draw these contours in the thresholded, original image, the IMG, right? So we will draw these contours in the IMG, right? So let's see the output, right? Okay, so can you see now the contours? So now you can see that there are many contours, right? Right. So what are the contours available here? Yeah, the 10 major contours. I mean, the major in the sense, the 10 big contours, and also, right? So we can see, okay, those 10 are there. And also the large one, like the large rectangle, or the square or the rectangle, it also considered as a contour. This one, I mean, right? And also you can see this tiny little, like, this is white, but it's a closed area, isn't it? These are also, like, they are very small, but they are closed areas. Yeah, see. So likewise, we have many closed areas, right? So if you count them, there are 4, 5, 6 contours, right? So including these tiny little white dots and white this area, right? The white area. And I mean, 10 contours are all also there, but in addition, these small things are also taken as contours, right? Got it? So now what we can do is, right, now here, this function, now what this function does, right? So if you put -1 here, now this is the contour color, I mean, the color that we are going to use to draw contours, and this is the line thickness. Now, if you put 1, the line is like 1 pixel, the thickness of the line is 1 pixel, the line that we use to draw the contours, right? So if you can increase it like 5, let's say, it's a very thick, I mean 5 pixel thick line will be used to draw the contours, right? So that's the thickness of the line, right? So you can view it from pixels. And this -1, what happens? This is the color, you know, BGR, right? So this is G and R. So that becomes yellow. That's why it becomes yellow. And this -1 here, we are asking to, like, let's use red color. And this -1, we are asked to draw all the contours, right? So we are asking to draw all the contours, right? That's what the -1 does, right? So if you put -1, that draws all the contours, right? Now, if you put 0, what will happen? If you put 0, this is the first contour of the contour list. It draws the first contour. So can you see the first contour? The first contour is the whole, I mean, the whole image, right? So it's also a closed area, right? Then, right? Then, like if you put 1, so this is the second contour, right? Now, can you see the second contour? So second contour is this 5 rupee, right? Likewise, let's see the 100th contour. So this is the 100th contour, and can you see where it is? So it is here, right? See? And also, if you want to see the last contour, how we are going to do that? You have to put 455 here, 455. Since it's like, so there are 4, 5, 6 contours, but the index goes from 0 to 255, so 0 to 455, right? Got it? So this is the last contour. Can you see the last contour? I can't see it. Yeah, it is there here. Can you see? It's the last contour, somewhere in the middle of this circle. Got it? Right. So that's how you are going to see the contour. Now, shall we see like each and every contour now? Shall we see the first contour? Right. So this is the first contour. You know, okay. No, I'm not going to get the first contour, but I will take the second contour. So the second contour is the fifth. I mean the fifth. The right. The number 5. All right. So here now, shall we see, right, what this contour is actually about, right? Okay. So now, can you give me a minute? Okay, so then yeah, so what I wanted to show you, okay, shall we print the contour? There are 456 contours. So shall we see the contour number 1? Contour number 1 is the, right? Contour number 1 is the right, this one, right? So what this contour 1, the second contour, right? So when you print it, you are going to see something like this. right? So let me like print the length of it and show you, right? So then you will get a better understanding. Right. So it says that there are 190 points in the sense like, yeah, the length is 190 of the contour 1, right? Got it? Uh, give me a minute. Sorry. Okay, right. So then, right. So can you understand what I mean when I print the contour number 1? You are going to see something like this, right? So can you understand what this contour means? Huh? So there are pair of values, right? Pair of values. Any idea what this is? What this is about? Huh? I'll explain. This is nothing, right? So we are going like, you can see that's highlighted near, huh? Which is highlighted. The now this is like the first contour, right? Contour number 1. We have drawn the contour number 1 here, right? So when you draw the contour number 1, you are going to see something like this. Right? You are going to see something like this. So then when you print that contour, you can see that there are many values and those values are in pairs, right? So what is this? It's nothing but the boundary points of this contour. The boundary points. That means boundary points in the sense, right? That means it's going to take these points, right? Boundary points. Right, boundary points of this contour, and it says like what this side mean when we print the length of contour 1, not length of contours. That means the whole number of contours. I mean, how many contours are there? Length of contour one means that how many points, boundary points are there in this first contour, right? So you can see 190 contour boundary points are there. So here you can see these values, right? So these values, what are these values then? Huh? These two values, can you identify what these two values are? Huh? So one column, sorry, one row represent a boundary point, right? So these are boundary points of this contour, right? Why there are two values? Yes. Why there are two values? Any idea? Why there are two values? Any idea? Yes. Huh? Yes, let's see. Yes, exactly. The x and y. See, each point has xy coordinates, right? See, right? So these are the xy positions of each and every boundary point. Right? Got it, right? Now, shall we go and see another, right? Another contour, like the contour number 2, right? So we'll check the contour number 2 and we will plot it and see, right? So contour number 2, right? So we even can't see that contour, right? So it's a very small contour, right? So can you see that contour, right? So it has a single point, see? What? Here, can you see that here? There's a contour, right? That's kind of a dot, right? That means it's represented by a single point. That means, yes, that contour can be represented using a single pixel, right? So this is the pixel position, right? I mean, the earlier one is like it consists of many boundary points, but here, like a single point. This contour is represented with a single point, right? And then, shall we see another contour, right? Contour 3, let's say. And we will draw it as a, that's also like it has a single value, right? A single point. Now we will move on like something like 10, let's say 10 contour. The 10th contour has four values, right? So it's not a single dot, like it's bit like, can you see? It is bit large, right? So that contour is bit large, right? Larger than the earlier one, right? So see this one. So here it is consist of 4 points. I mean 4 boundary points. In order to represent this contour that I have highlighted here, right? This one. So it has 4 points, right? So 4 points are there, and right. So those are the 4 values. Right? So now you can see like it's depend on the size of the contour, right? So how many boundary points should be there in order to represent that particular contour? It depends on the size of the contour, right? Got it? Understood? Now, if I show you again, right? If I show you again what? If I show you like the all the contours, right? If I show you all the contours now, okay, so these are all the contours that in this image, and to be specific, there are, right? To be specific, right? To be specific, there are how many? 4, 5, 6 contours are there, right? So now here we want to like only detect, right? Now you know that we need to only detect, right? I mean, this, I mean, 2 rupee, right? So we all want to detect 2 rupees, right? So now, do you have any idea? Like, can you suggest me a method, right? Can you guess me a method in order to sort, or in order to like filter? I mean, in order to sort the coins and only detect this 2 rupee, right? And also, I want to neglect these all these contours and all these other coins, and right. So what we need to do is we need to only take this contour. So can you suggest me a method? I mean, not I know I don't need the code. What I'm explaining is like, if you can identify a method, or if you can guess a method, like to like sort the, I mean, show filter the other coins and only detect the 2 rupee coin. Any idea? Yes, a simple method. Can you suggest? No? So what you can do is, right? So now, like instead of detecting, like drawing contours to all of these, I mean, drawing all of these contours, what we can do, if you can find a method, right? So if you can find a method in order to like I mean, simply say if you can find the area, right? If you find the area, let's say, what it means, huh? Like if you can get the area of each and every contour, and then like depending on the contour, we can sort these coins out, right? Got the idea, right? So we have a method. So what you can do is we have a method that we can find the area of a particular contour in pixels, right? So what's that method? C dot find contour area. C dot contour area, right? C dot contour area, and what we have to do is we have to pass a particular contour, right? That we need. Okay, let me pass contour number 1, and this gives you the area, right? Right. So let me yeah. Let me yeah. So let me show you the contour number 1 and its area, right? Right. So what it says the area is what? Area of this contour is what? Yes. It's like 12,463, right? This is in pixels, right? It's in pixels, right? So shall we see another pixel, another contour, let's say, right? So let me go to the contour number 2. What? Area is 0. Why? Huh? Can you remember this pixel was represented using a single pixel, right? Right. So single pixel is like there is no area, right? Area is 0. It is like it's a single pixel, so we can't calculate the area, right? Very single pixel, we can't calculate the area using a single pixel, right? Okay. So likewise, what we are going to do then, not like this, but we are going to go through each and every contour like this. What? For contour in contour. So we are going to go through each and every contour in our detected contours. Then what we are going to do, I'm going to measure the contour area of each and every contour. Right? So we are going to use a loop, and we are going to go through each and every contour and calculate the area, right? So shall we just print the contour area and see what happens? So how many times this loop will run? Any idea? How many times this loop will run? Four, five, six. 4, 5, 6, right? Exactly. So you can see like the contour area of each and every, right? So, right, the largest one, I mean, that whole image is 178, sorry, 170,872, right, pixels. Then the next one is 12,462. Likewise, we have many, yes, right? So I think like if you go through this, So you can see, right? Like we have 15,000, we have 5,000, we have 7,000, we have 7,000 again, right? And we have 10,000, right? So what we'll do, we will only draw, we will make a decision here. If the area is greater than 5,000 only, then we are going to draw that contour, not all the contours, right? We are going to draw the contour if and only, right? If only the contour area is greater than 5,000, right? Why? When I print those values, I saw that like there are large values, so we can assume that those large values are for the contours of coins, right? So what I'm going to do, I'm going to draw the only the particular contour, not all the contours, right? Only the particular contour, right? So let's see now what we can see. I will show this as well. So can you see? Okay. Now these tiny little things are not detected, right? These tiny little things are not detected, right? So again, what we can do again, right? Now we need the 2 rupee, right? So we need the 2 rupees, right? So let's see the other contour areas, right? And I think this is the so this is the largest value, right? I mean, this is the largest value, but that's for the whole image, right? So therefore, I think yeah, this one. So I think yeah, if you compare the value, I mean, the 2 rupee is the largest rupee, right? Here 2 rupee is the largest rupee. So when I go through the values, I saw that the largest value here is 18,000, right? 18,000. So I think that, right? So here you can see. So I think that's something that is the, right? That is the 2 rupees. So I'm going to draw like values, the contours greater than 17,000, right? 17,000, right? Yeah, I'm correct, but we have another problem. What? This one is also detected. The whole image is also detected, right? So therefore, we can have another condition, like what? Like we can get, okay, area is less than something, right? So for like we will use 20,000, right? Okay. Sorry, I put like greater than me. Okay, I should be less than 20,000. So let's see. Yeah, so done, right? Got it. Now we have detected only the 2 rupee coin. Right? We have detected only the 2 rupee coin, right? So using very simple code, right? So what we have did was we use the contour operation, right? We use the thresholding first, and we separated the background and the coins. Then we apply the contours, and we detected all the contours, and we use the area to detect the number 2. I mean the rupee 2 or 2 rupees. Right? So straightforward. I mean, very small application. But I mean, like we have only followed 3 major steps, right? But we were able to do that, right? But this is not the end. Usually, you have seen like when we detect an object, what we usually do is I think you have seen this, right? So detection means we draw a rectangle and say, okay, this is the whatever we detect, right? So in order to do that, what we can do, we can get this, right? We can get this contour detected. How? So instead of drawing it here, we have like if the area is greater than 17,000 and less than 20,000, what I'm going to do, right? What I'm going to do is I'm going to find the bounding rectangle. How we are going to find the bounding rectangle? CV2 dot bounding rect. C dot bounding rect, right? C dot bounding rect, and what it does is when you provide the contour, right? whatever the contour, it estimates the bounding rectangle for that contour. It estimates the bounding rectangle of that contour and gives you the x, y, w, and h, right? So what we mean by x, y, w, h, I will show you, right? Right. So what it does is, right? So the contour that this is the contour that we are looking, right? So this 2 rupee, right? Then what it does is it assumes a bounding rectangle, right? So it assumes a bounding rectangle, right? That means a bounding, well, the rectangle that bounds this thing, right? It's not going to draw it, right? So carefully, I mean, clearly understand that this rectangle won't be drawn, but instead of drawing it, what it does is it gets this parameters. What parameters? These corners, right? Okay. So these parameters will be given to you. What? X, Y, right? So the X and Y coordinate of this point. Which point? This point, right? And W and H, right? The height and the width of this rectangle, right? So those are the parameters given, and you can see, right? These are what I mean by X and Y, X, Y, W, H, right? So these are the values that the code gives us, right? That means X is 138, Y is 247, right? And height width is 156 and H is 155, right? Now, don't think that, okay, it gives this XYW. It's not going to draw, I mean, draw this rectangle, right? It's not going to draw this rectangle. Don't think like that. Understood? Right? Now, if you run this, right, it's not going to draw you a rectangle, right? So it's only giving you the XYW, see? Now this is that contour is drawn, right? So if I remove that one, right? So you can see, right? Only XYWH is the values are given, not it is not drawn, right? So we have to manually draw it now. We have XYWH and we can draw it, right? So in order to draw, right? In order to draw a rectangle in OpenCV, right? In order to draw a rectangle in OpenCV, what we have to do, in order to draw a rectangle in OpenCV, what we have to do is we have to provide these 4 values. But x1, x2, y1, y2, right? So this is how we can draw rectangles in OpenCV. You need to know x1, x2, y1, and y2, right? So let me draw you a random rectangle. I mean, right? So this is how we are going to draw rectangles. C.rect. So we have to mention where we are going to draw the rectangle. So we are going to draw the rectangle in IMG. Then we need to provide the x1, y1. So 100, x1, y1. Then x2, y2 we have to provide. So I will provide like, okay, 200, 250, right? Then you need to provide the what? You need to provide the color that you are going to draw. You are going to use the color that you are going to use to draw the rectangle, right? Then you have to provide the line thickness of the rectangle, right? So these are like nothing but this is x1, y1. This is x2, y2, right? Okay, so shall we? See, we dot rectangle. It's not rect. Sorry, it's rectangle. It should be rectangle. So this is not. This is a random rectangle I have drawn, right? So this means, right? So here 100, 100. So this is 100, and this is 100. And this is like x2 is 200 and y2 is 250, right? Got it? So now we have like xy/wh of the rectangle. Now, can someone tell me, right? If you want to draw the rectangle, right? If you want to draw the rectangle, right, around that coin, what are the values that we need to put here, right? Now, if you want the if you want the earlier annotation back, I will show you. Right. So in the coin, can you remember what it gives you, like xy/w? So tell me, like, those two parameters, I mean the values that we need to put here in order to draw a rectangle around the coin. I mean around the coin in the sense bounding the coin. Yes, very good, right? So it is x, y, and x plus w, y plus h, right? So very good, right? X plus w, y plus h, right? Okay. So then what we can do, if you run this one, now you can see a bounding rectangle around it, right? So now, I mean, this is not a big deal, right? But using simple image processing, we were able to do what? We were able to detect coins, right? Detect coin in the sense a particular coin. Like now you can change this area and detect whatever coin you like. Now, shall we do this and see like in a real video feed, right? So I will get some coins, right? Give me some time. I'll get some coins. I'm not sure whether it will be successful or not, but anyway, let's see, right? So now what I'm going to do, this is the testing, right? So we have prepared everything, right? So next what we are going to do is we are going to, right? So the same code, nothing else, the same code, right? So this same code, right? The same code I'm going to use, and I'm going to put that code inside, so here you can see nothing. This code is that code, right? Right. And I'm using my camera, right? I'm using my camera and I'm doing it for a video feed. Right? So I have put it inside the while loop. So this will be done using the camera. That's all, right? So nothing else, right? So now, shall we run this and see? I'm not sure. We have to adjust these values and change it, right? But now the thing is, right? So you know that when we the camera position matters, right? Camera position matters in the sense when we if you move the camera towards my face, I mean my face will get bigger and bigger, right? And when I move away from my camera, my face becomes smaller and smaller, right? So therefore, we set, right? We set 18,000 here, but it won't work when we change the camera, right? When we change the position of the camera, right? So therefore we have to adjust the camera and right. So we have to do lots of things, but let's try to do it and see. Right. So I'm going to get my camera, right? And I have a set of coins here. Let's see whether this will be right. Sorry, I had issue with the camera. Now let's do it again. Right. Now this is the threshold image, right? I want to get it. Now, can you see the coins are not detected, right? Coins are not properly detected. I will try to fix this camera. Right. And anyway, I think I will use my other camera. Let's see what will happen. Give me a second. Okay. Sorry for the delay, right? Okay, now let's try to do it. Right. So I have this thing with me, okay. Okay, now I have all the coins here, right? Now you can see, like with the light intensity and everything, you can see, right? So with the light intensity and everything, right? You can see that the coins are not detected, right? Coins are not detected. So what we have to do is, right? What we have to do is probably we need to, right? Okay, right. So now it's fine. Okay, right? So you can see the threshold, the image is like the coins are not like getting black, right? So can you suggest me what to do, right? Do we need to increase the threshold value or decrease the threshold value? What do you think? Now, like what we did is not working here. Why? Probably due to like the light changes, right? So there are many now the 2 rupee is not detected, right? So what you can see now, the coins are not clearly, right? Coins are not clearly detected. So any idea what we can do? The threshold value, do we have to increase it or decrease? What do you think? We have to decrease the value, right? So is it? I'm also not having an idea. Let's see. So yeah, probably it should be no, it should be increased, right? It should be increased, I think. I'm also not. Yeah, it should be increased, right? Why? We need more black pixels, right? More, we need to detect more black. So therefore, like we have to increase the value. So therefore, more pixels become black, right? So we'll increase the value again. Like I think this is too much or not. Let's see. That's too much. 150 is too much. So can you see now? This is what you are going to do actually, right? So in actual application, you have to change these things and get a like a good value, right? So this is also not that much good, right? It's also not that much good. So you have to probably change it, right? I'll probably change it now. I think the light intensity changes, right? So with the light, so we don't have a direct light. That's the light is also an issue, right? Lighting source. Anyway, I think that's we have to let's like reduce it. further. Yeah, I think now that's okay, right? Okay. Okay, I think it's fine, right? So now if you see the areas, right? So I have printed the area, right? So you can see I print all the area, right? The areas of the contours. So I'm not going to, yeah, I print the area and see like what are the values of the area. So it's 8,000, right? And it is, yeah, 5,000, 7,000, right? 9,000, right? So there are values like this. So what I'm referring here, right? So I'm printing the area, 6,000 is there, right? The contour area 8,000 is there. So I think like the contour, like let's say like 8,000, greater than 8,000 and less than probably 10,000. Shall we see what are the contours detected? Can you see? Now I'm doing this, right? So not randomly, I just print these values and see what are the contour values. So then you can get the idea what is like the 2 rupee, like the area of the 2 rupee, right? Why it should be the largest value, right? Likewise. So then now 10,000 is right. So when like what happens? Now the another rupee is also detected, right? 2 rupees are detected. So you can see this is a 2 and this is a 2. So 2 rupees are detected. And I think if we increase this further, the other coin will be neglected. Let's see. No. Yeah, 8,000. Yeah, I think the distance is also an issue, right? The distance is also an issue. So anyway, we'll get somewhere here. Yeah, okay, right. Now the shadow is also an issue. Now, when you put it here, can you see there's a shadow, right? So due to that shadow here, somewhere here, right? Not here, here, somewhere here, there's a shadow due to the light, the projection of the light, right? So if you move it somewhere here, that shadow removes. So now you can see only 2 rupees are detected, right? See, now we have many practical issues like this shadows and everything, right? So therefore we have to adjust these things, right? And what will happen now? This is what I mentioned. Now all of this, I mean, all of this will destroy it when you move the camera, right? Right. When you move the camera away, the area get reduced, right? The contour area get reduced, and when you, right? So when you get the camera closer and closer, the area got increased, right? So therefore we have to like fine tune them, right? So we have to test it and do it manually for the initial run, right? And also the camera position can be changed for this kind of application, right? Got it, right? Hope you got the idea, right? So you can do it for your uh, if you have coins or whatever, you can do it and see the output, right? Hope you got the idea. And now this is a very basic thing. I mean, basic sense in the sense, right? Like, uh, like you can see like a small code, right? And also here, in order to do this, we have some constraints, right? That means the background should be like a plain color background should be there. And also the camera position should be fixed, right? And also like no overlapping can be there, right? So that's another issue I didn't explain, right? If they're like the coins are overlapped or coins are connected, then that will be taken as a contour, right? So those kind of practical issues are there, right? Otherwise, this is a good method that you can right use, right? So now we use only what we used only the contour operations and image threshold, right? So then I skip some parts, you can remember, right? What this retrieval method as well as the approximation method and also this hierarchy, right? So now I'm going to explain. Actually, I'm not going to go in detail, but I will provide you some references where you can find and read what this retrieval method and the approximation method are, right? So you can go to the OpenCV official documentation, right? So I will right? So this is what I will share you the link. Right. So this explains more about contours, right? So I will show you some contour operations in here. Like you can, I just explained few, right? So I just explained you how to get the contour area, but you can get the contour perimeter. You can get the centroid. I mean the centroid CX and CY, the center of the contour of a contour you can get. We only discussed about the area, and also the contour approximation. You can like approximate it to a shape, like I mean uh, uh, like whether we can check whether it's a circle or a rectangle or whatever. Likewise, that's this contour approximation. And other than that, yeah. So I told you that the bounding rectangle, how to draw a bounding rectangle. And instead of, I mean, other than bounding rectangle, we have like the rotated rectangle. So what's the bounding rectangle is about? It's a straight rectangle. Now it's not rotating, right? But we have another rectangle called rotated rectangle. We can draw this rectangle into a contour. Like it try to draw this contour like by making the minimum area. So it tries to draw a rectangle for the objective of minimizing the area of this rectangle, right? So that's called the rotated rectangle. We'll discuss it later. And we can also not a rectangle, but we can create an enclosing circle and fitting ellipse, fitting line, right? So those things are also there. So these are for your additional knowledge. You can read this, and also the codes are given, so you can try them yourself, right? And the contour properties, right? This is something advanced. Contours, more functions. No, this is also not what I want to explain you. Yeah, the approximation method, I think it's there. Yeah, this one. So contour approximation method. What this contour approximation method is about this one, right? The last parameter of the fine contour function, the approximation method, right? So we can provide two approximation methods. There are two possible approximation methods that we can provide. The first one is chain approx simple. Other approximation is chain approx none, right? Chain approx none, and the other one is chain approx simple, right? So what happens in chain approx none and chain approx zero? So this example shows a very good, this shows a very good example. If you pass chain approx none, all the boundary points are stored, all the boundary points. Like for example, when you have like, let's say a rectangle like this, so it will detect all these boundary points, all the boundary points, right? So if you do it for this kind of rectangle, it will detect around like 700 points, right? But if you use chain approx simple, what happens? It will remove all redundant points and compresses the contour, and it saves the memory and time, right? So your code will run faster and the memory will be also saved. Why? Right? So in order to approximate this rectangle, like actually 4 points are enough, right? But if you pass chain approx none, all the points will be considered, right? But if you pass chain approx simple, redundant points will be removed, right? So that's what the approximation is about, method is about, right? So there are two things you need to consider. Like if you want to make it fast, right? If you want to make it fast and if you want to save memory, the chain approximation simple method is recommended. And also if you want to detect the contour very fine, very accurately, then the chain approx none method is recommended, right? So you can choose either, right? So then the next thing I want to highlight is the hierarchy, right? So the contour hierarchy, so that is about this retrieval method. So the retrieval method and this hierarchy, right? So this explains the retrieval method and the hierarchy. I'm not going to go into detail, but I will explain what is it about basically. Now there's a hierarchy when you detect contours in the image, right? So what it means is that now there can be parent and child relationship, like in the sense, now you saw like when there is a coin, inside the coin there was also contours, right? So in order to get that parent child here, now here this is the parent and this contour, the inside contour, like if you have a contour inside the contour, that's called a child contour. Likewise, we can get that parent child relationship this using this hierarchy. So the retrieval method, we have retrieval method. So the retrieval method is about how to get that relationship, the hierarchy. So we have many retrieval methods, external retrieval tree, likewise. So you can read about this, right? And this returns you the information about the hierarchy, the parent-child relationship, right? Got it? So I'll give that tutorial to you, right, for the further reading, right? Since it will take a lot of time if I explain all of those things, right? Okay, got it? Yeah. So now what I'm going to do, I'm going to move on to the day 2 materials, right? Right. So I'm going to move on to the day 2 materials, right? So you can get your day 2 folder and open the day 2 point processing and neighborhood operation, right? So we discussed about like the image thresholding, right? And also, yes, we discussed about contours as well, right? So we discussed about contours as well. And also we did this coin detection as well, right? So then I'm going to go to the next topic, right? Image histograms and image histogram equalization. So this is another topic comes under pixel-wise operation, right? So we are still in the main topic, like the pixel-wise operations, right? Got it? So then, yeah. Right. Okay, good. So then, yeah. What is a image histogram, right? I will explain image histogram, but in order to do that, I will get a sample image, right? So this image is there in your folder, the sample folder called unequalized, right? Unequalized. So then I will open that and I will show that image to you. Right. So this is the image that I'm going to consider for this example, right? So as you can see in this image, right? As you can see in this image, right? So it's a nice view, right? So probably captured from a top of a mountain, right? And you have a nice view there, and it's a gray image, and you can see the mountain and trees and some roads, right? And some paddy fields, probably, right? But you can see the images, but right, but there is something I mean some wrong, right? So there is a problem with this image, right? We can't exactly say, but I mean, what's the problem? But you can see by looking at the image, you can see this image is like unclear, not clear, but we can't say exactly unclear, but there's something, right? So in the sense, if I show you something like this, right? Right? Now you can see, okay, if I show you these two images, so you can see clearly, okay, now if you compare these two, then you can find the issue, right? So issue, like we can't explain the issue, what this issue exactly is, but you can sense that there is some wrong with this image, and this is the original image, right? Original image sense in sense, this is not the original image, but we are going to apply some image processing techniques, right? We are going to apply some image processing techniques and convert it to this, right? So then you can see that image is very clear, and that image is very like that image is quite okay, right, than the first image, right? So this is what you are going to do under image equalization, right? So this example I will show you, right? And right. So the image that I'm going to consider is this, as I mentioned. And if you take the shape of that image, right, this is what the image shape, right? So the number of rows and number of columns, right? So that means altogether we have pixels like 427,200, right? 427,200 pixels are there, right? Now what I'm going to do, I'm going to plot the image histogram, right? So I'm going to plot the image histogram. Do you know what a histogram is? Right? Do you know what a histogram is? Yes or no? Quickly. Let's see. Yes, others? If you are not familiar with histograms, tell me. Anyone? So I'm happy to explain it. If anyone here who is not familiar with histograms? No. Okay, fine. It's fine, right? So now a histogram is something like this. Now, if I draw a histogram, like let's say I'm going to go into a class, right? And I'm going to draw a histogram like this. Marks and number of students, right? Marks and number of students, right? So it's like this: 0, 10, 20. I'll do like this, 0, 20. Right, okay, I'm going to a class, right? I'm going to get a class, like I'm going to get the students, and I'm going to like, okay, maths marks, right? So the marks, the students that got maths marks, right? So I'm going to get the maths marks of the student in a particular class, right? And I'm going to draw a bar graph like this. What this bar graph means, right? So it's nothing but it shows the distribution of the marks, right? So there are, okay, 0 to, right? So let me use the dark color, right? So there are, okay, 0 to 20, right? So there are like 10 students who have got 0 to 20, right? Then okay, so we have around like 20 students, like, or 50 students, right, who has marks between 20 to 40, right? And we have like 40 to 60, we have something like this, right? And 60 to, and we have like something like this, right? And 80 to 100, something like this, right? So this is what you mean by a histogram, right? So we are going to get the distribution of the marks, right? So distribution of the marks, right? So that means, okay, maths mark 0 to 20, we have 10 students, right? So the mark distribution, right? Got it? And so this is what simply a histogram is about, right? In a very, like, very fundamental, very basic histogram, right? So this histogram is drawn for the maths marks of a, right, maths marks of a particular class, right? So the number of students who got this range. So we have, right? So what we are going to do now, we are going to draw the same kind of a thing, say, I mean, a histogram for an image, right? We are going to draw a histogram for the image. That means we are going to get all the pixels. Now, what we are going to do is we are going to flat the image. What we mean by flat? Right? Flattening in the sense. Do you have any idea about image flattening? What image flattening is about? So it's something like this, a quite simple process, right? Like image is in 2D form, you know that, right? Image is in 2D form, you know that already, right? So what we are going to do, we are going to make it flat, right? That means we are going to flat this image in the sense, we are going to convert it, right? We are going to make it a 1D one, right? How we are going to do it? We are going to get this row and we are going to put it like this, right? And this row, we are going to put it like, we are going to make this, right? Right? So simply what it means we are going to flat it. In the sense like, okay, this row is, we are going to take this row and we are going to put it here. And we are going to get this row and we are going to put it here. Likewise. Understood? Right? So if you have a, right, if you have like 8 by 8 image, there will be like 1D array of 64 elements, which is equals to 8 by 8. Got it? Got the idea? Right. So that's what you call flattening, right? So what I'm going to do, like, I can flatten the image. So it can be like image.flatten. So it makes it flatten. So this is how the flattening works, right? So I'm going to flatten it and I'm going to make I'm going to draw the histogram, right? Right. So the pixel value and the occurrence, right? So here. Okay, right. So this is the histogram, right? So now the pixel values, right? So pixel value, usually what's the range of the pixel value? Pixel value range in a gray image? Yes. Gray image. What's the pixel value range? Quickly. Huh? 0 to 255, right? Right. So now this image has 427,200 pixels, right? So this is the distribution of it, and we have split it to 100, right? So if you like, we can split it to 10 as well. So then we will see something like this. So 10 bars, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 bars, right? So can you see? So we have like 120 to 140, right? So we have around like 50,000 pixels, and 140 to 160, we have around like 200,000 pixels, right? Likewise. Got it? So this is the pixel distribution, like similar to the like maths mark distribution. This is the pixel distribution, right? Got it? Understood? Now there are like, okay, 140 to 140, right? So pixel values, right? If you take pixel values, okay, 120 to 140, right? There are pixels in the range 120 to 140. There are around like 50,000 pixels, right? And 140 to 160, if you take this range, there are 200,000 pixels in this image where the pixel value is between 140 to 160. Right, so that's what it says simply, right? Got it? Understood? So this is what you call the image histogram, right? Now you can see a issue here. What's the issue, right? So it has gray values, right? So you can see the distribution, it has gray values, right? That means majority of the pixels are around like 122, right? Right. So the majority of pixels are distributed between 120 to 200. That means the majority of the pixels are in the range of 120 to 200 pixel value, right? Majority of the pixels, they have a pixel value of 120, between 120 to 200, right? So that means this image is, the majority of this image is gray, right? The majority of this image is gray, right? So that's why you are going to see a grayish image, right? A grayish image. See, a grayish image, right? So what the image histogram equalization does, right? It does something like this. I will show you. So we can do something called equalize hist. This is called a histogram equalization, right? Histogram equalization. So what this equalization does, right? So you can pass the form, I mean the earlier image into this equalize hist function, that image, and you can get the equalized image back, right? So now I will show you the equalized image. So this is what you are going to get after doing, I mean, passing the image into this equalized hist function, right? And if you get that equalized image and if you see it flattened, and if you draw back the histogram, now let's see what the histogram does look like, right? Now you can see, now this is well distributed, right? It doesn't have something like it's not limited between 120 to 200. Now it is distributed evenly, right? Now it is distributed evenly in between 0 to 255, right? So that's why you are going to see a very colorful, not colorful, but very not grayish image, but a very clear image, right? Got it? So that's what you call image histogram equalization. Now, if you are wondering, okay, how this operation is done, right? How this operation is done. So that there are many methods of doing it, right? There are many methods of doing it, right? So, right, you can apply this equation, right? So let's say, no, like I'm not going to explain how this operation is done. Basically, it's something like comes under scaling, a topic called scaling and normalization, right? So I'm not going to discuss it here, but we will discuss it in our machine learning course. We will discuss about it now. For now, right? Just think this, okay? We are going to like evenly distribute this, this distribution. We are going to evenly distribute it and equalize it. So therefore, you can get a image like this, right? A very clear image, right? Now, these are again image processing. Why? Like if your image is not clear, right? If you have something like this, you can use equalization and you can get a very clear image like this, right? Understood? Okay, right? Hope you got the idea, right? Right. So that's what you call in histogram equalization, right? Okay, then we are going to go into the next topic of our workshop, right? Color segmentation, and this is a quite important topic, and we are going to do very interesting application using this one, right? So the application is basically like we are going to detect this right? So we are going to do something like this, right? Plant height detection using this application. So quite interesting application, right? Okay, right? So this will be our application. I mean, the project that we are going to do under the topic, the color, I mean, the color segmentation, right? So this also comes under this topic comes under again what? The pixel wise operation, right? Pixel wise operation. So we'll move on to it, and let's see what the color segmentation is about, right? Give me a sec, give me a minute. Okay, right. Uh, uh, okay, right. So color segmentation again, right? So what the color segmentation is about. So again, this is another topic that comes under, as I mentioned, image processing, the pointwise operation or pixel-wise operation. So this is about detecting objects based on color, right? Now here, the example that I showed you like a minute ago, right? So here now we are detecting, right, based on the color, right? So here you can see we have applied the contour operations, and I mean not the contour but the thresholding, but here you can see the object is detected based on the color, right? Now there are many other, I mean the background is in a separate color, there is this container and there's soil, right? So there are many objects in this right? So there are many objects in this image, as you can see, the container, the background and the soil, right? So there are many things. So what we are going to do, we are going to use the color, and depending on the color, we are going to detect objects. So we are detecting this using the green color, right? So that's what this color segmentation is about, right? So if you are going to segment, now here we have done segmenting. Why I call segmenting, right? So we have from the original image, we have segmented this part, right? We have segmented this part. So that segmentation is done based on the color, right? Got it? So that's what the color segmentation is about. So that's what we are going to learn now, right? Okay. So right. Okay. So when we are going to go into this color segmentation, right, or color segmentation, there is a very important color space that we need to learn. That is HSV color space, right? So the RGB color space is something that we are familiar, right? So that's the color space that we can understand, right? Got it? So the RGB color space is easier to understand for humans, right? That means we know, okay, any color in this world, right? So that's what we know about RGB. So we know that any color in this world can be created or can be obtained from by mixing R, G, and B components, right? So if we can get pure green, pure blue, and pure red, we can mix them in like appropriate amounts, and we can get any color in this world, right? So we can get infinite number of colors, right, in this world, right? So that's what you call RGB, right? So RGB is basically like the addition or the mix of three main components, R, G, and B, right? But thing is, when it comes to computers, right? So when it comes to computers, computers are not good with RGB color format, right? Computers are not good with RGB color format, but for computers, they can be very efficient. Computers can be very efficient, and these programs can be very efficient if they use HSV color format, right? HSV color format, right? So HSV color format, again, we have three components, right? Three components like hue, saturation, and value. So, I mean, any color, right? So if you take a color, that color can be represented with RGB, or else, I mean, similarly, that color can be represented with HSV as well, right? That color can be represented with HSV as well. Now, you know this, I showed you last week, right? Now here, you can say, okay, this color 50, 168, that's the RGB component. So if you take the HSV component of it, this is how the HSV values represent that color, right? The same color, we can, right? We can, if this color, right? So this color, if you represent it using RGB, this is how the representation you can see. And the same color, if you represent it using HSV, this is how what you are going to get. 136, 70, 66. 136, 70, and 66. Understood, right? So any color, like, right? So I mean, the same color can be represented in two formats, like RGB or HSV, right? But thing is, RGB is convenient for us. RGB is easy for us, humans. But HSV is the color format that computers can deal easily with, right? Computers can deal easily with, I mean, easy with HSV than RGB, right? So computers prefer HSV format. So we are going to learn about HSV, what it means by HSV. But RGB, you know that RGB color format has three main colors, three separate colors, RGB. So we can mix them and we can create a single color. That's what RGB is about. But HSV is not like that, right? So we try to understand what HSV, why we are going to understand HSV, and why we are going to learn HSV color format or the color space. Since for color segmentation, what I showed you earlier, color segmentation, detecting objects using color, that's what you call color segmentation. So for color segmentation, we use the HSV color format, right? So in order to understand HSV color format, we have to know what H means, what S means, and what V means, right? So H is hue, right? So hue is about the pure color, right? Hue is about the pure color, right? Hue means the pure color. That means something like this, right? Okay, now this image is a bit misleading, but for now, let's assume, okay, let's assume this is 90, and this is 180, and this is 270, right? Right. I will like, it changes, but for now I will explain like this, right? So what it says, right? So H means the pure color, right? That means if H is 0, right? H is 0, that is red. That means it is red, right? If you say, okay, H 0, that means pure red, right? If you say, okay, H is 120, that's pure green, right? H is like 120, that's pure green. If you say, okay, 180, 240, right? So when you say 240, that's pure blue, right? Pure red, pure green, right? Pure green, pure blue, right? Understood? Okay, so here 0 hue is pure red, 120 is green, and 240 is blue. Right? Got it? Right? Okay, so that means the pure color, right? Understood? So, I mean, pure color in the sense, each color, right? Now, this is a bit confusing and interesting, right? That means each color has a hue value, right? Each color has a hue value. That means yellow is like something around 80, right? And this cyan color is something around 180, right? So this purple is around 270, and this the pink is around like 300. See, so each color has each color has a hue value, right? So that means the pure color, right? So each color we can represent it using the hue value, right? So it is a pure color. So green has like 120, red has a hue value around 0, and this blue color is around like 240. Likewise, it has a color. It has a each and every color in this world has a number that has a separate H value, hue value, right? Understood? Right? Got it? And then what is S? Right? What is S? Now, can you understand the difference? Okay, RGB are 3 different colors, but here HSV like it doesn't talk about like color components. It say okay, H is the color, H is the pure color. By changing the S, the color can be changed. So H is independently, H is about the color, right? Then saturation is about the amount of color used, right? The amount of color used. That means, okay, that if you select, okay, like this, okay. If you select H to be 0, right? So if you select H to be 0, okay, H is 0, right? And if you select S is 0, what that means? That means this color is black. Sorry, not sorry. That's not means S0 means this is gray or white we can say white, right? And if you put like okay, H equals 0, right, and S equal 100%, right, H equal 100%, that means this is pure red, right? Pure red, right? Pure red. Now you can see it here, right? Okay, you can see it here. Okay. Now if you right, okay, so now carefully understand this. Now, okay, let's say this is a particular H value now here. Okay, let's say this is 90, right? This is H90, right? This is H90. Now, this is the like when you are going to see from the top, you are going to see the H value, right? And I'm going to select this 90, let's say, right? This 90, okay. So then I come here, okay, 90. This is the H value 90, right? Right? So this is where S is 0, right? S is 0, and this is where S is 100%, right? That means what? If you select, okay, H equals 90, and if you put like S0, S equals 0, that means like white color. And if you put the saturation, if you make the saturation component 100, that means the purest color of this color, this H value 90. So H90 is a particular value, you know that, right? Now each H value is a pure color. H value is a pure color. Each and every H value represent a pure color, a different color, right? So now we have selected the color 90. H equal 90, that's a color. And if you make H0, that's white. And if you make H100, that's the purest color of that color. This color. Right. If you use 50, there is 50% of that color, like, right? 50% from that color. It's putting 50% of that color, right? Then the other component is value, right? So value controls, right? So here, value controls the brightness, right? So if the value is 0 here, if the value is 0, that's the darkest one. And if the value is 100 here, right? Here you can see value is 0, that's the darkest color. And this is the 100, that means the brightest color of that H90. Understood? Got the idea, right? So now, okay. So H90, right? H90. And if you select okay, saturation 50, that means somewhere here, right? And if you select value is like 10, this is the color. This is that color. Right? And if you put okay, saturation 50% and value 100%, this is the color, right? Understood? Got it? Got the idea? Right? Okay. Understood? Or do I need to explain it again? Right? For example, right? See, H0, 0, 0. That's black, right? And we make it 100. Right? So we'll do something like this. Okay, we will make it 100, right? And we are going to make it 50, right? So what it means? Okay, we are in red color. We can't change that. We are in red. Why? H is the color, pure color, right? We are in red, and we have like we have put 50% from the color, right? So this is 10%, right? So that means the amount of the color we are going to use, right? 0 simply refers to black. Sorry, 0 simply represent like 0%. That means white color, right? If it is 100, that we have here we have put 100% of that pure color 0, right? And the third component is the value. It controls the brightness, right? So if like the 0, that means black, right? So if you put 50, right? Can you see the brightness? It controls the brightness. And if you put 100, that's the purest color, right? Now 120 is about like the purest green color, right? Got it? So each color now, if you put 90, or if you put like let's say 45, right? So that's something like yellow, right? So each H value has a color, an independent color, and value controls the amount of the saturation controls the amount of color used, and the value controls the brightness of that color, right? So that's how the HSV works, right? But in OpenCV, right, like theoretically H is from 0 to 360. Why? It's in a kind of like a circle, right? And the S is from 0 to 100%, and V is from 0 to 100%. But in OpenCV, right? So this is real scenario, right? But in OpenCV, these are like right? So these are not in these ranges, right? In OpenCV, these ranges are changed, right? OpenCV, H is considered to be in between 0 to 180, and this is in between 0 to 255. This is between 0 to 255. Now, the explanation remains the same, but the value ranges are a bit different, right? Got it? Okay, so I will finish it from here today, right? Got it? We are going to finish it from here today. So what we are going to do now, tomorrow, we are going to start with this H. Now, you have to have the understanding about the HSV value components, right? And then we are going to use this concept, and tomorrow we are going to like see how we can use these HSV values and how we can detect, we can do color segmentation, how we can select particular color ranges and detect objects from that, right? Okay, so I will finish it from here today, right? So tomorrow we are going to use this HSV color space, and we are going to use it for color segmentation and object detection, right? Okay, so if you have any questions, now it's the time you can ask. Otherwise, we can wind it off for today, and we will meet again on tomorrow, 7 p.m. I hope you got the Python tutorial and the modules tutorial. So please go through them, and also the codes that we explained today as well, right? So please go through them and get them covered. Okay, so seems no questions are there, so therefore we will wind up for today. And good night, everyone. Please be there 7 p.m. tomorrow, and we will start from the color segmentation tomorrow, right? See you again.